Hi students, welcome to Map My Tutor. This is VVG, your maths mentor for IITG. This season, I'm coming with the KCET 2025 PYQ discussion, okay, which is very helpful for your 26 examination. We are very near to the examination. That's why you must be very serious about PYQ preparation so that you can understand the difficulty level or weightages of the topics, different topics, okay? So all these going to be very helpful in your final examination, right? Let us start the paper discussion. Here is your question number 1. Consider the following statements. The first statement is given, the set of all solutions of the linear inequalities. Two inequalities are there. Okay, you can observe that. 3x plus 8 less than 17 and 2x plus 8 greater than or equal to 12. Or some solutions here they mentioned, right? And also statement 2. Depending on these two inequalities only, they are asking the solution set. And your job is to verify which statement is true, which statement is false. Come on, let us do the first one. So 3x plus 8 less than 70. So if I send 8 to the other side, 3x less than 9. So x less than 3. Come on, the first solution, x less than 3. Is it there? Yes. Come on. Now let us take the second one. 2x plus 8 greater than or equal to 12. So 2x greater than or equal to 4. And hence x greater than or equal to 2 is the second solution set. Yes, it is. Therefore, statement 1 true. Because same solution sets are mentioned there. Now, to verify the statement 2, just we have to take the common solution. And look at that. In one condition, x is greater than or equal to 2. And the other, x less than 3. That means what? X lies between 2 and 3. But 3 excluded because only less than 3 is allowed. And greater than or equal to 2, that means 2 is included. But here, observe this set. Open interval 2 to 3. You know what is meant by open interval. The endpoints are not included. That's why statement 2 is false. So, conclusion, statement 1 is true, statement 2 is false. Where it is. Statement 1 is true, but statement 2 is false. Yes, option D. Okay, got it? It is a simple question from linear inequalities. The number of 4-digit even numbers that can be formed using the digits 0, 1, 2 and 3. Come on, these are the given digits. Without repetition, of course, the condition. And you need only 4-digit even numbers. We know that even number means it has to end with an even digit, right? Therefore, I got two cases. The case 1, either it ends with 0. What is the other case? It can end with 2. 1 and 3 can't be there in the unit position. Why? Because if 1 is there or 3 is there, it is to be considered as odd number. But here it is even number. So, whenever 0 is there, of course, 0 is fixed here. What are the remaining digits? 1, 2, 3. And remaining places? 3 places to be filled. 3 non-zero digits and 3 places to be filled. 3 factorial ways. Without repetition, right? Next one. 2 is already fixed. What are the remaining digits? 0, 1, 3. And remember, 0 cannot be there in the thousands place. If it is there in thousands place, it cannot be considered as a 4-digit number. And therefore, I can fill this digit in 2 ways. I can't fill in 3 ways. I can't use 0. Okay? And already 2 is used in units place. That's why I can use either 1 or 3. And the second position, 2 ways. And third position, 1. And total number, 2 into 2 into 1, that is 4 ways. And hence it is 10. So how many 4-digit numbers are formed? 10 4-digit numbers I can form using the digits 0, 1, 2, 3 without repetition. Yes, option A is correct. So if 0 is not there, why second case I got 4 only? If 0 is not there, then second case also 6. In that case, the total number will be 12. And look at the options. 12 is also given in the options to mislead. Suppose if any student forgot that 0 is there, he may consider that what first case as second case 6 plus 6, that is 12. But 10 is the right answer. The number of diagonals that can be drawn in octagon. Octagon means the number of sides is 8. Very, very important. Octagon. Number of sides is 8. Number of sides is 7. Number of sides is 6. Different names are there. Like number of sides is 5. What is that? Pentagon. 6. Hexagon. Like that. So for octagon it is 8. And to find the number of diagonals, there is a direct formula. Don't waste your time. Straight away I am using the formula n into n minus 3 by 2. And what is n here? 8 into 8 minus 3, that is 5 by 2, which gives you 20. Therefore, the option A is correct. So there is a direct formula. See, you can save time in these modules because you have to use that time to some other questions. Okay. So not all questions like the third number, right? The number of terms in the binomial expansion. Look at this binomial expansion. 2x plus 3 power 3n is 22. This is the number of terms. Again a direct question. See, if the power is 3n, the number of terms is always equal to that power plus 1. 3n plus 1 is how much? 22. That's it. Suppose if it is a plus b power n, the number of terms would be what? N plus 1. But here the power is 3n, so 3n plus 1. So it is 3n is 21. What is n? 7. Come on. 7 is the correct answer. See how easy it is. They're all like fundamental models. Based on straight away that number of terms means the index plus 1, the power plus 1. So 3n plus 1. Okay. Got it? A simple calculation. 4th, 10th and 16th terms of a GP are x, y, z. Look at the number 4, 10, 16. The gap between 4 and 10 is 6. 10 and 16 is also 6. That means what? I am taking 3 terms from a GP which are equidistant. So if 3 terms equidistant are taken, they are also formed a GP. Simple logic. That means what? X, Y, Z form a GP because they are the terms taken equidistant, not consecutive, but equidistant. In that case, if X, Y, Z are in GP, you know in a GP common ratio must be equal. Therefore, y by x must be equal to z by y. Come on, cross multiply. You will get y square equal to what? Xz. Is y square equal to xz? What is y? Root over xz. And you also know that y is called geometric mean. If 3 terms are in GP, the middle term is called geometric mean. Where is that? Of course, in the first option. Y is equal to root over xz. Yes. So here, just to test you, they are not given consecutive terms, but they have given equidistant terms that you must observe. Okay. If A is a square matrix such that, look at this condition, A square equal to A. That means if you multiply A with A, again you will get A. Okay. Then what is I minus A whole cube? Anybody, can you just suggest one matrix which satisfies this condition? Very well known matrix, that is identity matrix. If you multiply I with I, again you will get I. So I always satisfy this condition, A square equal to A. But not only I, many other matrices also can satisfy. And there is a special name. Whenever A satisfies this condition, A is called idempotent matrix. It is called idempotent. If A square is A is called idempotent. Of course, it is not in NCERT, but may be useful for your IIT purpose. Okay. Now, using this condition, I have to evaluate I minus A whole cube. Of course, you know I is identity. But don't attempt I minus A whole cube straight away. It is easy to calculate I minus A whole square. Because I and A commute each other, it is easy to expand just like A minus B whole square. What is that? I square minus 2 into I into A plus A square. It is just like A minus B whole square. Okay, A square minus 2AB plus B square. Because I into A and A into I are equal. And we know I square is I. And I into A is A. A square, of course, A. It is given. Therefore, I got I minus A. So once I minus A whole square is I minus A, then try to find I minus A whole cube, which is I minus A whole square into I minus A. Just now I proved I minus A whole square is what? I minus A into I minus A. And therefore it is I minus A whole square, which is again I minus A. See, it is recurring. Therefore, the correct option is D. Not only I minus A whole cube. You already observed I minus A whole square is I minus A. Even I minus A whole cube is I minus A. Therefore, I can confidently tell I minus A whole power n is I minus A. So, in this question, I can generalize this result. I minus A whole power n is always equal to I minus A, provided this condition. If A square is A, then only this is correct. Got my point? A and B are two matrices such that AB is an identity matrix. That means what? AB equal to I. And the order of matrix B is 3 cross 4. So, B is 3 cross 4. And then the order of matrix A. So, what can be the order of matrix A? Let me consider order of matrix A as M cross N. You know the matrix multiplication rule. What is that? Matrix multiplication of two matrices is possible only when the number of columns in the first and number of rows in the second must be equal. That means what? This n and 3 must be equal, otherwise A into B is not possible to define. That's why A must be what? M cross 3. And B is already fixed, 3 cross 4. So, M, what about M? Now I got to know, what about M? So, M is not known, of course. Here, already the right side they have given us I. I is always a square matrix. And we know that this 3 and 3 won't appear in I as the order. Therefore, it is M cross 4. There is a rule. If A is M cross N matrix, B is N cross P matrix, their product will be what? M cross P matrix. Accordingly, if A is M cross 3, B is 3 cross 4, what is their product? It is M cross 4. But as already I told you, I must be square matrix. What is meant by square matrix? The number of rows and number of columns must be equal. Therefore, M must be 4. And hence, I must be a square matrix like this, 4 cross 4. So, finally, they are asking the order of the matrix A. I assumed that it is M cross N. Already I got M as 4 and N as 3. Therefore, it is 4 cross 3, second option. What do you understand here? What is the simple principle involved here? If A is M cross N, B is N cross P, AB must be M cross P. And the product of two matrices is possible only when number of columns in first, number of rows in the second must be equal. Okay? Just a fundamental concept. Got it? Which of the following statements is not correct? Just read the statements. Okay, cool. We'll read the statements, we understand, and which of the statement is not correct. I want to explain an important hint or point, what you have to say. Whenever this model is there, you underline this word because sometimes they will ask you which of the following statements is correct. Sometimes they will ask you which of the following statements is not correct. Suppose if you are already preoccupied mind with the correct, because most of the times we get which of the following statements is true or correct, some kind of thing. Okay? Never be preoccupied mind with the correct or not correct. Read it and underline it. So, not correct. Okay. A diagonal matrix has all diagonal elements equal to 0. Not correct. It is not correct. Why? Because what is diagonal matrix? It is a square matrix in which non-diagonal elements are zeros. That's why our option is A. Because they're asking not correct. Now, just for knowledge purpose, what about BCD? Let us check. A symmetric matrix A is square matrix, which is satisfying A dash is A. A dash means A transpose. Of course, it is a definition of symmetry. That means this is correct. But according to our question, it is wrong. Why? I am asking not correct statement. Don't confuse. A skew symmetric matrix has all diagonal elements equal to 0. Yes. That means it is not correct for us. Not correct means statement is correct, but it is not our answer. Okay. And a row matrix has only one row. Yes, that is also correct, but not our answer. Our answer is, which is not correct. A diagonal matrix has all diagonal elements equal to 0 is a not correct statement, which is our answer. Okay. Again from matrices, A is given 1, 1, 1, 1 is satisfied. This condition, A power 6 equal to K into A dash you know, transpose of A. Then what is the value of K? So anyway, we cannot calculate A power 6 straight away. Therefore, what should I do? Let me check with A square first. You know A into A. Therefore, it is 1, 1, 1, 1. Again 1, 1, 1. And we know matrix multiplication is carried by row column method. 1 into 1 plus 1 into 1, 2. And all the other elements will be same because same numbers are there. Next, I'll approach to A power 4, which is A square into A square. Anyway, I calculated A square, right? So, 2, 2, 2, 2. And then 2, 2, 2, 2. Again, row by column method. Yes. Just calculate first row, first column, enough. 2 into 2, 4 plus 4, 8. No need to calculate the remaining elements. You can write the same. Now, finally, I need A power 6. A power 6 is nothing but A power 4 times A square. A power 4 is already there. And A square also there. Again, first row, first column, if I multiply 16 plus 16, that gives you 32. And all the remaining elements, 32 each, which can be written as 32 times 1, 1, 1, 1. And what is this 1, 1, 1, 1? A. But they are asking A dash. Then what is A dash? It is also 1, 1, 1, 1. Therefore, I can write this as 32A or 32 A dash. Both are same. A and A dash are same. Okay. And hence, the K is 32. Option D is correct. Okay. And I ask you one question. Here, I found A dash and A are equal. In that case, can you name the matrix? If A dash is A transpose equal to A. That means it is symmetric. If A dash is minus A, it is skew symmetric. Okay. They are nothing but definitions. If A is K to 2K and data of A cube is 125, then the value of K. So, what is the matrix A given? K to 2K. And data of A cube is 125. We know by the property of determinants, data of A cube is det A whole cube. What is that property? Data of A power n is det A whole power n. And therefore, what is det A? 5. Because 125 is 5 cube. Now, coming back to this. If A is K to 2K, what is det A? K into K, that is K square, minus 4 must be equal to 5 according to this condition. So, what is K square? 9. What is K? Plus minus 3. There it is. Option A. Simple. So, only thing is you have to write this properly. Det of A cube is 125. Det of A cube is det A whole cube. Okay? It is a basic property in determinants. If A is a square matrix satisfying the equation, there is an equation in terms of A. It is called matrix equation. Okay? That I is identity, O is null. It's already mentioned where I is the identity matrix and O is the null matrix of same order. Then what is A inverse? Right? So, A square, let me analyze this equation. Okay? And 7 into I can be written as A into A inverse by definition. Why I am introducing A inverse? Because I need A inverse. Okay? So, that is the first idea which leads to the solution. I is the identity matrix which can I of course expressed as A into A inverse. A into A inverse is always I, that is by definition. Now, I'll shift these two terms to the other side. 7a inverse is equal to what? 5a minus a square. Now, a small adjustment here. A can be written as a into I because I is the identity matrix. That is a property. If you multiply any matrix with I, you will get the same matrix. Therefore, A can be replaced with A into I. Now, I can use the left cancellation law in matrices by taking A out. See, like this. In the right side, I took A common. Here also, I have written A separately on the left side, and I can cancel this A. It is not like algebraic cancellation, but there is a law called left cancellation law in matrices. And if I cancel that, then I'll get 7A inverse, but I need A inverse divided by 7. So 1 by 7 times 5I minus A. So A inverse is what? 1 by 7 times 5I minus A. And where it is? 1 by 7 into 5I minus A, option D. Okay, very close to that is 1 by 7 into A minus 5I. Be careful, okay? Again, matrices. If A is a square matrix of order 3 cross 3, A is a 3 cross 3 matrix, square matrix of course. And that A is also given 3. Then what is the det of 3A inverse? Determinant of 3 times A inverse. And look at this. If A is 3 cross 3 and that A is 3, definitely A is non-singular matrix. That is, if that A is 0, it is called singular, for which A inverse does not exist. But that A is 3, non-zero number. That means definitely it is a non-singular and A inverse exists, and that A inverse is also a 3 cross 3 matrix. Correct or not? Of course, yes. If A is n cross n, A inverse also must be n cross n, right? Now, using that, again coming back to the determinant property, det of 3 into A inverse can be written as 3 cube times det of A inverse. Why? Because det of k times A is always equal to k power n times det A. This is what the basic property again, where n is the order of the matrix A. If A is n cross n, okay? So here A inverse is 3 cross 3. Therefore, I should get 3 cube out, which is 27. And det of A inverse is again a property, 1 by det A, which comes from A into A inverse is I, okay? And det A is 3. Come on, substitute 27 times 1 by 3, which is 9. Where is that? Option C. So, here I have used one more property from determinants, that is det of A inverse is 1 by det A. These are the two things you must remember, okay, with which we can easily finish this question. B is 1, 3, 1 alpha, okay, is the adjoint of a matrix A. So, B is the adjoint of A. Let us write in the equation format. B is the adjoint of a matrix A. That means adjoint of A is B, or B equal to adjoint A. And det A is given as 2, of course. Then the value of alpha, that unknown, okay? And if I apply det on both the sides, since B equal to adjoint A, det B equal to det of adjoint A. And again, one more property from determinants. What is det of adjoint A? Det A power n minus 1. Again, n is the order of the matrix. If A is n cross n, det of adjoint A is det A power n minus 1. Here, what is the order of A? We don't know exact what is A, but det A is 2. But we know the order of B is 2, and B is adjoint A, therefore A must be 2 by 2. Therefore, det A power 2 minus 1, which is 1. So, det B must be equal to det A. That's what I proved. Now, det B, I can calculate from B. What is that? Alpha minus 3 equal to det A already given. Therefore, alpha equal to 5. See how I got alpha minus 3? Everybody know. To find the det of a 2 cross 2 matrix, I use a formula kind of thing, that is AD minus BC. Actually, definition is separate, a different one, but I can use it as a formula. AD means what? Product of the diagonal elements minus product of the non-diagonal elements. So, that B is equal to AD minus BC. AD means 1 into alpha, that is alpha, minus 1 into 3, that is 3, equal to that A is 2, and hence alpha equal to 5. So, option A is correct. Okay. The system of equations 4x plus 6y equal to 5. Definitely write that equation. 4x plus 6y equal to 5 and 8x plus 12y equal to 10. Okay, has infinitely many solutions, unique solution only to know like that. That means your job is to find the number of solutions of these two. Okay, I'll explain with the help of geometry. We know every linear equation x and y represent a straight line. So the first one represents a straight line. Second one represents a straight line. But do you observe, if I divide by 2 the entire second equation, what I'll get? Again the first one. 4x plus 6y equal to 5. That means whatever the two lines they have given us, they are coinciding lines because the same equation. Okay. In coordinate geometry, they also tell that like the ratio of the respective quotients like this, even constants, all are same. If the ratio of the respective terms or quotients are same, then they are coinciding lines. Okay. And once the two lines are coinciding, the number of solutions is infinite because every point on the first line is also there on the second line. So this is how we can explain with straight lines very easily. Actually, there is one more method using determinants. Okay, that also easy, but this is more easy. Why? Because suppose if these two lines are parallel, can you tell me what is the solution? No solution. If two lines are intersecting, then can you tell me what is the solution? Only one. That means unique. Two solutions anyway not possible. Just for the options purpose they have given us. Okay. Here vectors are given A bar, B bar and C bar. Three vectors are given such that one condition is there. A bar plus lambda B bar is perpendicular to C bar. Whenever two vectors are perpendicular, what is the condition? Their dot product is 0. That is, here A bar plus lambda B bar is perpendicular to C bar. That means dot product. And your job is to find the unknown. What is the value of that lambda? Okay. So A bar plus lambda B bar dot C bar equal to 0. And of course, we can expand this bracket, dot product bracket. I'll get A dot C plus lambda is anyway constant times B dot C equal to 0. This is 0 only. It's a scalar. Okay. So our job is now to find out what is A dot C and what is B dot C. Of course, finding the dot products is quite easy. What is A dot C? Come on. This is A and this is C. What is the formula to find the dot product? A1, A2, B1, B2, C1, C2, add them. That is quotients of I, quotients of J, quotients of K. Multiply, add all the products. Now, let us do it for A and C. 1 and 1, 1. 2 and 1, 2 plus 2. And plus 1 and plus 1, 1. So, 4. That is A dot C. And how to find B dot C? Same, but now between B and C. Count 1 and 1, 1. Minus 1 and 1, minus 1. And plus 4 and 1, plus 4. Therefore, it is 4. And therefore, it is 4 plus lambda times 4 equal to 0. And hence, lambda is minus 1. 4 plus 4 lambda 0. That means what? Lambda is minus 1. And option B is the only correct answer. Look at that. There is plus or minus. No. Only minus 1 is correct. Okay. Got it? So here what is the point? If dot product is 0, then it is the two vectors are perpendicular to each other. If the dot product is 0, then two vectors are perpendicular. What happens if cross product is 0? Then the two vectors may be parallel. Okay. If they are parallel, like or unlike, whatever it is, then cross product will be 0 part.